my next question for you, leaning into that idea of digital developments and changes over time, how do you see the synergy between advanced platforms and AI powered diagnostic tools accelerating our ability to detect, differentiate, and even monitor complex diseases like Alzheimer's in the clinical setting?
Yeah, thanks, Marcy. I'm very happy to share a view, and I've spent a lot of the last couple of years trying to upskill myself on the value of quantum computing, machine learning, artificial intelligence. And the context for me is, I studied artificial intelligence as an undergraduate, which is a very long time ago. It's last millennium, and I'm not going to be any more specific than that. So it didn't feel new to me, but what feels new is I think the mechanics, the architecture upon which we can run these AI algorithms. So part of that education process was me going to the Quantum Computing Summit in London a couple of years ago, and discovering in 3 to 5 years we're probably going to have accessibility to extraordinary computational power. And just the thing that resonated for me, so I'm always keen to share and pass on, is current digital security systems are almost certainly going to be made redundant by the onset of quantum computing. That's a very stark message, and definitely made me sit up and listen to the rest of the session. So I'm very optimistic that we're going to have this very substantial computing power. And we've also got the algorithms, one hopes, that will yield interesting data at the end of that process. And I think we've always suspected there might be metrics in our databases that are unpredictable. Maybe they're not things that we go to. I looked at that example of memory, but other areas of cognition. Maybe if we were looking at executive function measures or concentration measures, there might be something that pops out and says, look, I look like a really good metric. I'm capturing things that are important and relevant, and it might take parse of a very large data set with powerful computing and good algorithms to let those things stand out. Not least because some of those might be a combination of things. Maybe it's not one metric, it's actually a combination of metrics that really gives you the evidence of change, the sensitivity, the validity, and the reliability that we've been looking for. So I come to it with huge enthusiasm and optimism. If I had a reservation, it would be about whether the data we're going to be able to put into these analyses has the rigor and value that we hope it does. So I think if I look at some of the endeavors that I know are going on in the UK, we have Our Future Health, very ambitious program, ultimately designed to capture the healthcare parameters of millions of Brits. It's great we're collecting that data now, because presumably when the accessibility comes up, we can then put it into the system and see what we find. My ex-colleagues at Scottish Brain Sciences endeavouring to do the same thing for the people of Scotland. So I'm very optimistic about those databases because they're very rich. There's blood information, there's CSF information, neuroimaging, genetics, lifestyle factors, a whole host of things going into it. And I think that could be very, very valuable. Sorry, Marcy. And the other thing, just to sort of put into that equation is we do have rich clinical trial data. My concern would be that the cognitive and the functional data might not be as valuable as we would hope it would be, largely because of the issues that I discussed in the answer to that earlier question.